I think that a great source of training data, and there are several, a great source of training data are full physics simulations, right? So we've got customers who say, hey, I don't have historical data. I got a design out in the field. The engineers have all retired, okay? The new engineers have no idea how it works. The test data is written in pen and paper and locked in a cabinet somewhere, or it accidentally got thrown out. So how do I build up training data on historical designs? I know that they're in the field. I know they're reliable, but that's not enough. A reliable design is not enough to feed into a sim model. So reverse engineer that, put it in a full physics model, FEA, structural dynamics, CFD, heat transfer, whatever, and solve it. And get that model to match your test data. Do it again. Do it again. New temperatures, new flows, new forces, new displacements, new temperature profiles. Just start creating data sets, millions and millions of data points with spatial discretization, right? So 3D CAD files, all the data, temporal, right? So transients, right? And that data, when it matches existing test data, you can fill up gigs and gigs and gigs of hard drives and use that to train. The test data, on the other hand, is not full field, right? I don't, when I make a heat exchanger, I don't know the full temperature field of that heat exchanger. I don't have enough thermocouples. I can't afford enough thermocouples. I've got maybe half a dozen thermocouples. I've got maybe an IR camera, and I'm using, all of their own, sort of error, but I'm feeding that in. So you really have to get, I think, a mix of training data, but the quantity side of the training data, that's going to come from simulation, no doubt.